Hello guys, this day we'll be tackling about memory management. What is memory management? Memory management is the process by which a computer operating system handles and controls the use of memory or RAM. What are the examples? For example, when you open Chrome, Spotify and a game, the OS assigns each app of portion of RAM. For example, Chrome gets more memory tabs, Spotify gets memory for the music player, then the game gets more memory for graphics and data. Memory management makes sure each app has enough space without crashing or overlapping. In memory management, we have key functions including allocation, deallocation, protection, swapping or paging, and tracking. Memory allocation. This is the process of assigning memory space to different programs or processes when they are loaded into the system. What are the examples of memory allocation? You open a Microsoft Word. This gives a Word of version of RAM to, to store the app code, the document you're editing, the temporary data. This is called memory allocation. Memory deallocation. This is functions free or release memory that is no longer needed by program after it has finished running. For example, you close the Microsoft Word. Now the OS removes Word from RAM and frees the space so other programs like Chrome or Game can use it. This freeing of memory is called deallocation. As for next is memory protection. Prevents one process from accessing or modifying the space of another process. For example, you're not running Chrome and Spotify at the same time. Chrome cannot read or change Spotify's memory and Spotify cannot access Chrome's tabs. If an app tries to access that isn't assigned to it, the OS blocks it and may show an error. This is memory protection. Memory organization or management tracking. These functions keeps track of each memory location, which areas are in use, which are free, and how memory is divided. It helps the operating system efficiently allocate and manage memory resources. Memory sharing. Memory sharing allows multiple programs to use the same memory space safely, especially they need to access the same data or files. It improves efficiency, reduces duplication. As in key feature, we have virtual memory management. This function uses part of hard drive as an extension of the main memory RAM. When physically memory is full, it allows larger programs to run and helps the system handle more tasks simultaneously. Memory management main techniques. Number 1. Contiguous allocation assigns a single continuous block of memory to each process. Number 2. Non-contiguous allocation divides memory into segments or pages allowing program to use separate memory blocks. Number 3. Paging and segmentation techniques that breaks memory into smaller units for more flexible allocation. Number 4. Virtual memory uses part of hard drive as extra RAM to extend memory capacity. Number 5. Garbage collection automatically frees unused memory in programming environment like Java or Python. And the next is challenges of memory management. Fragmentation. Memory can be divided into small, unusable pieces over time. So, internal fragmentation happens when allocate memory is slightly larger than need. External fragmentation occurs when free memory is scattered, preventing large allocations. Efficient allocation and deallocation. The system must allocate free memory quickly and efficiently. Poor management can slow down performance or cause memory leaks when memory is not released properly. Protection and security. Ensuring that one program doesn't access or modify another program's memory is a major challenge. Without proper protection, data corrupt and security breaches can occur. Limited physical memory. When RAM is insufficient for running multiple large programs, the system has to rely on virtual memory, which can slow down performance because it uses hard drives as temporary memory. Swapping and paging overhead. Using virtual memory involves moving data between RAM and disk storage. This process, known as swapping or paging, can cause delays and reduce system if done excessively. Managing multitasking environment. Modern systems run many applications at once. The OS must efficiently divide memory among them without causing crashes, delays, or interference. As for last, balancing performance and resource use. Memory management system must strike balance between fast performance and efficient memory usage. Too much optimization in one area can negatively affect the others.